Hi everyone, so my name is Gabor. I work for a company called Actility. Who is familiar with the company called Actility? Not so bad, I was expecting something worse. So just 1 second to spend on our company. So Actility provides today software-based network, IoT network management solutions to all the big operators that are currently deploying IoT networks, specifically using the LoRa technology that I will mention later. We raised close to 100 million euros. The latest one was announced a couple of weeks ago when we raised 75 million euros. We are based in Paris. We are close to 160 people in the company. The core of the team is based in France, in Paris, but we have now offices a little bit everywhere in the world, obviously because we have to follow our clients wherever they are. Okay. I'm here to talk this afternoon about IoT. Obviously, once you said IoT, you said mostly nothing. It's something that is very big, very broad. We can put many things inside. Sometimes people have no idea what they are talking about. So it's a huge topic. Obviously, I will not speak about all the IoT this afternoon. Otherwise, I would need a little bit more time. What I really want to address today is what we call the LPWA, so low power wide area networks. I'm pretty sure that you're quite familiar with all the other technologies in the IoT landscape, like the cellular connectivity, satellite, Wi-Fi, Zigbee, Z-Wave, Bluetooth Low Energy, stuff like this. The particularity, the specificity of all these technologies is that they are consuming a lot of power. So they are draining battery like hell. If you have a mobile phone, you probably have to recharge your mobile phone every night or every other day if you have a very good mobile phone. This is obviously not something that is suitable with the world of IoT. Most of the studies tend to show that in the coming 4-5 years, we are going to have between 20 and 120 billion connected objects in the world. Obviously, if you have to recharge 20 to 120 billion objects every night, it's not going to be possible. So the main topic today in IoT is really the battery life. So whoever is able to propose a technology able to correctly manage the battery life and the power consumption will be clearly the winner of the IoT landscape. Wi-Fi, battery not good. Cellular, not good. Satellite, not good. Let's say 3 technologies appeared a couple of years ago on this new segment that is called LPWA that are very good in managing the battery life of the connected objects. And this is the main value proposal of this market segment, which is called the LPWA, so low power wide area networks. You probably heard about Sigfox. Who is familiar with Sigfox? Cool. LoRa. Who is familiar with LoRa? A little bit less. Narrowband IoT? No one. Good news. There are other technologies, but the 2 main technologies today on the market who are quite, let's say, mature and ready for business are Sigfox and LoRa. So these are technology names. Okay. Oh, sorry. I think that I actually used the wrong slide deck. we are having many decks. Yes. The mic is working. Now it is working. But don't worry, they were the same slides. Okay. Okay. So this one is better. So actually, to show you that the market is huge. Talking about the technologies, as I was saying, this is the sweet spot of IoT, and this is where the new technologies like Sigfox and LoRa are arriving today. So the 2 main technologies are, as I mentioned, Sigfox and LoRa. The good news is that both technologies are from France, which is very cool. It's always very fun to see Japanese and Korean and American companies come to France to choose these technologies to deploy in their countries. When you know that in South Korea and Japan, they have like a generation of advance in telco networks, it's very rewarding to see them come to France to buy one of those two technologies. So the first one on the market was clearly Sigfox, like 4 or 5 years ago. They almost launched this market segment. But of course, other technologies arrived like LoRa. So the main difference between the two technologies is that Sigfox is a closed standard, which means that you don't have access to the specifications of the standard. Today, only Sigfox is authorized to operate and to manage a Sigfox network. So if you want to deploy, let's say, an IoT network to cover, let's say, Algolia, with a complete control on the network, you cannot do it with Sigfox. LoRa, on the other side, is something that can be used as an open approach because all the standard is free to access to. It's completely open. All the standardization is managed by an entity called the LoRa Alliance, which is like 500 big companies in the world that are united to develop this technology. So on one side, you have Sigfox, and on the other side, you have LoRa. A disclaimer here, Actility today works mainly with LoRa, so we are not working with Sigfox for the very simple reason that we are not allowed to work on Sigfox. Only Sigfox is allowed to work with the Sigfox network technology. The important thing to bear in mind is that on these technologies, we are talking about very, very low data rates. We are talking about 100 bits per second for Sigfox, 300 up to 5.5 kilobits per second for LoRa. This is very, very low. If you remember the 56 kilo modems we had 20 years ago to access the internet, it was very slow, but it was still 10 times faster than what we have on this LPWA technologies. But it doesn't matter because here we are talking about use cases like telemetry, like sensors, like very small temperature sensors that will send a very small amount of data. We are talking about 50 bytes, 100 bytes from time to time during one specific day. So it's perfectly fine to use these kind of data rates, okay? LoRa is a completely bidirectional technology, which means that you can receive data from your IoT devices, but you can also send data, which is very important because it means that if you have a lamp, let's say, you can switch it on and off. You can send commands to switch it on and off. If you have a motor, an actuator, you have a street light, anything, you can send and receive information. Sigfox has also this capability, but is limited. When you are looking to their commercial offer, basically you are limited to 4 downlinks per day per device, which means that it works, but it's not going to be adapted for most use cases. Because if you can turn on your lamp only 4 times a day, yeah, maybe not the best course of action. So as I said, from a network standard perspective, Sigfox proprietary LoRa is completely open. The interesting thing is about the price of the connectivity. You probably pay like 10 euros per month for your mobile phone to have, let's say, almost unlimited connectivity. On the LPWA market, whatever the technology that you are going to use, we are talking about very low priced connectivities. We are talking about an average. It can be a little bit more or a little bit less, but the average would be around €1 per month per device. Okay. For the simple reason is that all these devices are going to send maybe 10 packets a day or 50 packets a day, but it's still very, very small and very, very limited. So this is the basic architecture of a LoRaWAN network, but it's also, let's say, the same in Sigfox. So the purpose is to deploy a dedicated network. You all know that our mobile phones are connected to a public network of gateways or base stations that are installed mainly on high points, buildings, towers, and so on. And these gateways, they provide large connectivity to the users. For Sigfox and LoRaWAN, it's exactly the same principle. It's a really dedicated and independent network from the cellular network that is deployed by mostly public network operators. So in France, obviously, the Sigfox deployed their network using the Sigfox technology, but you have also Orange, who deployed LoRaWAN network that is covering all the country. Also Bouygues Telecom with their subsidiary Obgenius, who deployed a public LoRaWAN network. So basically, you just have to buy a couple of devices and you can very easily connect them to this kind of public network. And again, the benefits is that your device will be able to last several years, and I'm saying years, without having to recharge your battery. If you take some use cases like connected smoke alarms that will send information through a LoRa or through a Sigfox network, all these devices, 99% of the time, they will send 1 or 2 packets a day. In this scenario, the device will last almost 10 years from a battery perspective. So you see that it's really cool compared to the existing technologies that we have in cellular or in Wi-Fi or all the other IoT technologies. Going back to the architecture, all the gateways are connected to a centralized network server. So it's basically the brain of the network, and this tool it's purely software-based tool, huh? No hardware, it's purely software-based management platform, and it is used by the operators, so like Orange or Sigfox or Bouygues Telecom, to manage their network, to manage the devices, the gateways, the connectivity plans, the billing, and so on. And then all these information are exposed to any kind of third-party application. So if I'm going back to my example about the smoke alarm, if someone builds this smoke alarm using LoRa and Sigfox and develops a mobile application to receive some kind of alarms or alerts from the device, say there is too much smoke or maybe there's a fire, typically the operator's network will push the data using protocols like WebSocket, MQTT, usual protocols to send the data to the application's server. Okay, so from an architecture point of view, is very simple. And this is why the solution is very cost efficient. Compared to a 4G or a cellular network, is almost 100 to 1,000 times less expensive. So when Orange has to spend like billions and billions to upgrade the mobile network to 4G by deploying new gateways and stuff like this, they only need to spend 10 to 20 million euros to deploy a network that is able to cover a country like France. Okay. So this is what the Sigfox network coverage looks like today. You can see that they are very, very strong and very present in France, in Spain, a little bit in UK and in Germany, and they are progressively deploying networks a little bit everywhere in the world. Almost time, okay, so we have to finish quite soon. On the other side, LoRaWAN is covering a little bit more because as an open standard, anyone can deploy large-scale networks without having to pay much. So this means that the deployment of the networks can go much, much quicker. Finishing on the use cases, this LPWA market opened the perspective of many kind of new use cases that were not able to be done before. So it can be like connected buildings with all kinds of sensors, because you don't have to plug them to a power source. It's very easy to deploy temperature sensor, motion sensor, smoke, fire detection system, smart parking sensors, light piloting systems, energy consumption, energy monitoring meters. On the smart city verticals, you have applications such as smart parking, the street lighting piloting. It can be waste management, how you're going to monitor all the waste bins. It can be all the energy harvesting, the smart metering, electricity, water, gas metering. It can be tracking. Tracking is really, asset tracking is really the killer application of LPWA, because today most of the trackers have a battery life of a couple of days or maybe weeks if you're lucky. Using LoRa or Sigfox, their battery life can increase to months or even years. And this is very important when you have to monitor containers going from China to the US, or the routes are very long, so you cannot recharge your tracker. This is why it's very important to use technologies such as LoRa or Sigfox. You have smart agriculture, you can monitor the soil moisture. There are virtually an infinite level of use cases that can be deployed. I even seen connected mouse traps, rat traps, connected through LoRa. And this is, you're laughing, but it's a very interesting use case, because all the facility management companies, they are deploying these mouse traps in the walls everywhere. And actually, when it catches a rat or a mouse, no one is notified. So the mouse will remain there, it will stink, it's not going to be very healthy. And the building facility manager has to send out periodically people to visually inspect the status of all these mouse traps. So this costs money, it's not very efficient. Using LoRa or Sigfox connected mouse traps, they can receive an alarm saying, I killed a mouse or a rat, come and get the dead mouse. So there are many, and this works because you don't have to recharge the battery of very often of the device. And there are many use cases available on the market. So it's still what we call in strategy a blue ocean market, which means that there are not so many competitors, application providers, or device suppliers on this market, because it's a new market. So everything is to be built, and everything is to be done. So it's a very exciting time for IoT, and more specifically for LPWA-based IoT for Sigfox and Laura. So I think that I'm pretty much done. Any questions? Yeah. There was another one there as well.
Thank you. Thank you for talk. Just one question. It's a new question. So let's say you have a device and I want to deploy it in Italy, France, Spain, Brazil. Do we have to negotiate with each of each service provider for each country I want to deploy my device in, or is there kind of a global LoRa offer?
So when you're buying a mobile phone today, how are you doing?
Yeah, I know.
So it's the same principle. Sigfox,
well, there are some
easy.
Global SIM cards, global contracts.
Sigfox is easy because it's only one universal operator. So it's going to be Sigfox in France, it's going to be Sigfox in Italy, in UK, in America, in South Korea. It's still going to be Sigfox. So it's fairly easy. On LoRaWAN, it's slightly more complicated because basically each operator is going to have its own network. But because it's a standard, all the networks are interoperable. And roaming is a feature that is already standardized. And there are already roaming agreements between the operators.
Right.
So you just have to buy one connectivity, and then you are traveling around, and then automatically, like with your mobile phone, the roaming agreements are going to apply.
Okay. And LoRa, I guess, is multi-frequency, so there are different frequencies from in Europe as compared to the US. And does the an average antenna covers 2 or 3 frequencies that are supported in different countries?
Yes. So this is about to be finalized. Until today, we had only devices that were working specifically on European frequencies or US frequency framework or the Asia framework. But now there are new modules that can work literally everywhere in the world.
All right. Okay. Thank you very much.
There was another question, I think, there.
Hello.
Sorry. Hello.
I would like just to get back to the question of logistics and tracking.
Yes.
You just talked about the battery life specifically. As far as I understand that, the technology that is mostly used for this kind of things are air feed technologies, like short-range ones. And in this case, the air feed tags, they don't even need to have any battery connected. When you said they have short battery life, did you mean the readers?
So if we talk about RFID, how does it work? Basically, you have to have a tag on your object
Yes,
to track,
exactly.
and you have to go through a gate that will, because it's a very, very short range technology, we are talking about something less than 1 meter. So you have to go through a gate. So basically, you will be able to track your device only at specific points.
Yeah, but the readers, they can be transported. It can be a pretty tiny thing. It's not necessarily a huge, gigantic gate.
Yeah,
right.
But here we are talking about use cases where you need to monitor the specific location of your asset, wherever it is, even in the middle of the Sahara or in the middle of the Pacific Ocean,
it's less the question
or
of
inside a warehouse.
Okay,
so the purpose here is to have a universal tracking solution that would work literally everywhere without having the need to install specific reading gates inside your warehouse.
I see. Thank you.
Hey, I have a question regarding the security. Okay, because you can sniff the wireless. Wave, and you can receive information and hack the device. So what about LoRa and Sigfox?
So it is true that virtually everyone can sniff everything that goes through the radio networks. Now, in Sigfox and Laura, of course, they are not completely stupid. So they installed many encryption protocols inside the protocol. So specifically in LoRa, there is a 2-level encryption. There is a network encryption of each packet with an AES 128-bit algorithm. And then there is also an application level encryption of the payload, which is also encrypted with another AES 128-bit key. And all these keys, they are managed securely inside the networks. Inside the LoRa Alliance, all the big security players are very active. The Gemalto, Oberture, Morpho, Safran, G&D, they are all in the LoRa Alliance, and they all provide secure, very high security grade key management systems for the operators to manage all these encryption keys. So yes, you can intercept, you can sniff, but you can't do anything with the packets.
Thank you.